Hello friends, in this video we are going to discuss a example on the Fermi-Dirac statistics. So the example looks like this. There is a n-type semiconductor and the Fermi level position of this n-type semiconductor, that is EFN, lies at 0.3 electron volt below the conduction band. Now the temperature of this n-type semiconductor will be increased. So let us assume the temperature is increased to T equals to 330 Kelvin. Now what will be the position of the Fermi level at this given temperature? That means the Fermi level position EFN should be determined at T equals to 330 K. For this, we know that for a n-type semiconductor, the shift of the Fermi level can be drawn in a energy band diagram like this way. So this is the conduction band, this is the EC, this is the EV, and this will be the valence band. Now if this is the middle of the band gap or EFI, now EFN lies at 0.3 electron volt below the conduction band, means the position of the Fermi level is at T equals to 300 K, and this gap is given by 0.3 electron volt. Now we have raised the temperature to T equals to 330 K. So the shift in the Fermi level of an n-type semiconductor can be written as EC minus EFN is equals to KT ln ND by Ni. So we know that from this equation we can see that EC minus EFN is proportional to the temperature, and EC minus EFN is given by 0.3 at 300 K. So we can write that at T equals to 300 K, the value of EC minus EFN is given by 0.3 electron volt. So at T equals to 330 K, it will be 0.3 divided by 300 into 330 electron volt. So, after the calculating and simplifying, we can find the answer as 0.33 electron volt. That means at 330 electron volt, the gap or the shift of the semiconductor Fermi level will be 0.33 electron volt, and it has been increased. That means the new position of the Fermi level will be somewhere at this position, and this value is given by 0.33 electron volt, and this is the EFN value at temperature equals to 330 K. So, this is the new position of the Fermi level of the given N-type semiconductor. So, this is all about this example. Thank you.